Okay, in this section, we're going to be simplifying trigonometric expressions, and we're going to do that by using those same identities that we just learned. It says to simplify a trig expression means to rewrite it as a numerical expression or in terms of a single. It's very important. We're going to try to write these. Notice this has a secant, a sine, a tangent. It has three different trig functions. We're going to try to write it in terms of just a single trig function, just one, just a sine or just a cosine or so on and so forth. Identities are useful in simplifying these expressions. So here's some strategies over here to the left. Rewrite using reciprocal and quotient identities. What I like to do is actually try to write everything in terms of sines and cosines. Just makes it a little easier. Look for Pythagorean identities or a possible way to create one. So look for some sine squareds or cosine squares. Anytime you have those squareds, you probably are going to be using Pythagorean identities. You can combine fractions using common denominators. You can break apart fractions possibly, and sometimes you might have to factor. So that's all strategies that we're going to use to solve or to simplify these expressions. Something else that I'm going to keep handy as we're doing these is my trig identity sheet. And you can see all those reciprocal identities we covered, the quotients, we've done the Pythagorean, the cofunction, and the even odd. So that's the identities that up to this point that we have worked with. So here we go. Let's try a problem. And again, the first thing I like to do is try to write everything in terms of either a sine or a cosine. Like secant, I know from my reciprocal identities that secant is equal to 1 over cosine. And then I have is equal to or minus sine times tangent, and from the quotient identities, I know tangent is equal to sine over cosine. So that's what we now have. So I have 1 over cosine. Now I can multiply my two fractions, and that would give me a sine squared over cosine. And I don't even have to find, I have two fractions here. I'm going to use this third strategy, combine using a common denominator. Well, I've already even have a common denominator, and that's cosine. So I'm going to leave my cosine on bottom. I'm going to put 1 minus sine squared on top. Now, anytime you see that sine squared, start thinking Pythagorean. And let's go to the Pythagorean identity that involves the 1 and the sine squared. Now, it doesn't look like it fits exactly. So what we're going to do to make it fit is I'm going to take this sine squared and I'm going to move it to the other side. And when I do that, that turns my identity into cosine squared is equal to 1 minus sine squared. So notice that what's on the right side, the 1 minus sine squared, is exactly what's in our problem. And 1 minus sine squared is equal to cosine squared. So what does that mean? I can take out my 1 minus sine squared, and I know that from my identity just now that it's equal to cosine squared. So that turns my problem into cosine squared over cosine. Use your rules of exponents. If you have x squared over x, subtract those exponents, subtract 2 from 1, you're left with 1. Same thing here. Cosine squared over cosine to the first is cosine to the first. So therefore, that is equal to cosine. And then I usually put my angle back in there. The entire problem, I'll just write the sines and cosines and all those. Then at the very end, I'll put my angle back in there. So we've written this in terms of a single trig identity now, or trig function. And the next one, sine of A plus cosine times tangent. Again, I like to write everything in terms of sines and cosines. Those two are already fine. And I know from my quotient identity that tangent is equal to sine over cosine. So I've got to multiply these two. The cosines will actually cancel, and that leaves me with sine plus sine. Same as if you had x plus x. That's equal to 2x. So sine plus sine would be 2 sine, and then I'm going to put my a back in there. So therefore, I've simplified it to 2 sine a. Okay, number 3. We can look to try to possibly factor this. That would be difference of squares would be one method. The other method, as soon as I see squares, I think Pythagorean. So let's go to our Pythagorean identities here, and let's see if we can do anything with either one of those. I know that, let's see, we're dealing with our problem in cotangent squares and cosecant squares. So here is a cotangent squared and cosecant squared, the relationship. Notice cosecant squared is equal to this. So what I can actually do is take out my cosecant squared and plug in cotangent squared plus 1. So now I would have cotangent squared minus, now put it in parentheses as you plug it in. Again, I said cosecant squared is equal to cotangent squared plus 1. So let's take it out, plug that in, which is what it's equal to. Distribute that negative gives me cotangent squared minus 1. These will cancel each other out and leaves me with simply -1. So I actually had every one of my trig functions cancel completely. So no matter what angle, this is what this means. No matter what angle you put in here, whether it be 30, 45, 60, 70, 156, when you plug it in and you square them and subtract them, you'll always get the value -1. Okay, next up, sine times. Okay, so that'd be the sine times. Tangent will be sine over cosine, plus cotangent will be cosine over sine. We're going to divide that whole thing by the cosine. So some strategies here. Let's say we could go ahead and distribute. When I do distribute, I see that it would actually cancel this out. So we can do that first before we find common denominators. Might make it a little bit easier. So this would be sine over 1. When you multiply it by your first fraction, you'd have sine squared over cosine. Plus the sines would cancel, and the second one would leave us with just the cosine. And I'm going to put cosine over 1. And that whole thing is being divided by cosine. Equals. Okay, now on top, I am going to find a common denominator, and that common denominator would be cosine. So the way I'm going to do that is multiply top and bottom over here by cosine. And I have cosine squared over cosine. So now the tops can be added. That gives me sine squared plus cosine squared over cosine. And again, that whole thing is over cosine. If you'll look at this top, again, anytime you see sine squares and cosine squares, you're thinking Pythagorean identity. And if you look right here, I know that sine squared plus cosine squared, which I think it was written as cosine squared plus sine squared on the previous one. That's fine. Sine squared plus cosine squared will always equal 1. So we're going to take this out right here, and we're going to put in its place 1. So 1 over cosine divided by cosine, and that'd be cosine over 1, is going to equal, okay? Let's flip and multiply, and that'd be 1 over cosine times 1 over cosine, which would be 1 over cosine squared. And if we can at all help it, you could leave it like that, but to get rid of that fraction, we know that 1 over cosine, let's go back to our reciprocals, 1 over cosine is equal to the secant, so we could actually rewrite the 1 over cosine as the secant squared. And now let's put our angle back in, which was just x. So that whole thing simplifies to secant squared x. Number 5. Again, cosecant I know is 1 over sine minus cotangent squared over cosecant. Well, cotangent squared, I know cotangent is cosine over sine, so cotangent squared would be cosine squared over sine squared. And then we have divided by 1 over sine. The second fraction, the second complex fraction, let's go ahead and flip and multiply. So I have 1 over sine minus, that'd be cosine squared over sine squared times sine over 1. Sine squared and the sine cancels. You have 2 on bottom, 1 on top, so only one of them is going to cancel. And we now have 1 over sine minus cosine squared over sine. So that actually did us a favor. Now we have a common denominator, so we can combine them by doing 1 minus cosine squared over sine. Okay, next up, if you notice on top, you have ones and squareds. Anytime you have ones and squareds, you're thinking Pythagorean. And the one that connects cosine squared with 1 and sine squared is this first one. However, mine says I have a 1 minus cosine squared. Well, let's manipulate this to where we turn it into 1 minus cosine squared. The way we're going to do that, we have the 1 over here. We'll move the cosine squared over there. And we see that sine squared will equal 1 minus cosine squared. So in the place of 1 minus cosine squared, we can put sine squared. So on top, we now have sine squared, and on bottom, we have sine. So we have two of them on top, one of them on bottom. So the one on bottom cancels with one of them on top and leaves me with just a single sine. And our angle was theta, so let's go ahead and put that back in. So my function here simplifies to simply the sine of theta. Number 6. On top I have cosecant minus sine. Cosecant is 1 over sine. And I'm subtracting minus sine, which we're going to write as sine over 1. On bottom I also have cosecant, which is 1 over sine. Now, this, you could finish working it out like this, find a common denominator right here. But let me explain to you that sometimes there's better ways. Now, let me show you a better way here that I think is going to work much quicker than this way. I'm going to take and I'm going to split this because that was, I want to show you another one of the strategies, which was breaking fractions apart. Now, anytime you have a single value on bottom, sometimes it might be helpful to break this apart. And this is the exact same thing as the distributive property x minus 3 over 3 can be split into x over 3 minus 3 over 3. It's the exact same distributive property. That's what we're about to use here. The cosecant on bottom, we're going to take the top and we're going to split. And the reason I see that this might be useful is I have another cosecant here. And when I split it and I do the cosecant over the cosecant, that's going to be just a value of 1. And then I have over here sine over cosecant. So that's going to be cosecant divided by itself is 1 minus. Then over here I have sine over cosecant, which I know is 1 over sine. When I flip and multiply, I will get 1 minus sine squared. Again, that's fairly simple, simplified. However, I can go a step further by using this exact same trig function, Pythagorean identity, that I've been using on several of them. Let me erase this and clean it up, because I now have, again, 1 minus sine squared. Well, take this sine squared and move it over. 1 minus sine squared will equal cosine squared. So therefore, 1 minus sine squared, I can replace it with cosine squared, and let's put our beta back in. Okay, number 7. Here we can find a common denominator first. I'm hoping to be able to plug some stuff in and maybe it'll clean up a little bit before I do. I don't know if it's going to or not. So my secant here, I'm going to write as 1 over cosine, and then you have divided by sine, minus sine over cosine. Now this first fraction, I can go ahead and flip and multiply. So that's going to give me 1 over cosine times 1 over sine. So that's going to be 1 over sine times cosine minus sine over cosine. And it did help me a little bit with finding a common denominator there. Now I will need on the bottom of this, I'll need a sine. So let's multiply top and bottom by sine. So I now have on top 1 minus sine squared. And I have my common denominator now on bottom, which is sine times cosine. I know that I can replace, again, by the exact same Pythagorean identity. 1 minus sine squared, if you manipulate this, I actually just did, 1 minus sine squared will be cosine squared. So I can now replace that with cosine squared. And then I have a sine times cosine on bottom. Let's cancel out the cosine on bottom with one of the cosines on top. And I now have cosine over sine. And according to your quotient identities, cosine over sine is equal to cotangent. So that whole thing simplified into the cotangent of u. Next problem. Tangent is equal to, now don't make this mistake, you can't split this and write it over this minus and then write it over this. You can only split it when you have the single thing on bottom, or the single term on bottom and multiple terms on top. So the tangent on top we're going to write as, let's write it as sine over cosine. On bottom you have secant, which is 1 over cosine, minus cosine over 1. Okay, the bottom, we have a fraction that we can find a common denominator for. So I'm going to multiply here, top and bottom, by cosine to give me a common denominator. So that'll be a cosine on bottom and a cosine squared on top. So I now have sine over cosine on top. My common denominator creates a single fraction on bottom, 1 minus cosine squared over cosine. 1 minus cosine squared, that's your Pythagorean identity again. So I now have sine over cosine over 1 minus cosine squared will be sine squared for the exact same reason as all the others over cosine. Let's now flip and multiply. You have sine over cosine on top times the reciprocal, which will be cosine over sine squared. The cosines cancel out completely. The sine on top cancels with one sine on bottom and leaves me with nothing on top and a sine on bottom. So 1 over sine, which we know is equal to, by the reciprocal identities, the cosecant. And our variable was alpha. Number 9. Notice on top you have conjugates. And we know that when we multiply conjugates, we get difference of squares. So let's go ahead and distribute that out, FOIL it out. You get cosecant squared minus 1 on top. And you have a cosecant squared on bottom. Now, it's going to be very tempting to try to cancel these. You cannot. You can, however, split this. If you would like to write it, split the fraction as cosecant squared over cosecant squared, then you could cancel. Minus 1 over cosecant squared. Anything divided by itself is equal to 1. The reciprocal 1 over cosecant. What I can do there, let me flip back. 1 over cosecant, according to my, let's see, where's it at? 1 over cosecant is right here. 1 over cosecant is equal to sine. So 1 over cosecant squared will equal sine squared. And that's our Pythagorean identity again. 1 minus sine squared is equal to cosine squared. And that is x. Number 10. Tangent plus cosine over 1 plus sine. Now, I want to show you a cool trick that works on these. A lot of times, especially if you have like a 1 plus sine, well, I know if I had like 1 minus sine squared, that's when that whole Pythagorean stuff works. Well, you can actually create 1 minus sine squared. You can create 1 minus cosine squared, 1 minus tangent squared, 1 minus cotangent squared by using this trig. I'm going to take and I'm going to multiply top and bottom by the conjugate of that bottom. And the reason I'm going to do that is I know that when I multiply conjugates, I get difference of squares. And look at the difference of squares here that this is about to turn into. I have tangent plus, on top I have cosine times 1 minus sine. And on bottom, I'm going to have 1 minus sine squared after I multiply that together. And notice I did not go ahead and distribute this. I would just leave it for just a second. I'm going to leave my tangent over there. So now I have 1 minus sine squared on bottom, and I know that 1 minus sine squared I can turn into cosine squared. And the reason I did that is I can now cancel this cosine, and that's the reason I didn't distribute, with one of the cosines on bottom. Now over here, this tangent, again, I'm going to write it as sine over cosine. And it worked out great because now I actually have common denominators. So I have the common denominator on bottom of cosine. On top, I have sine plus this stuff, 1 minus sine. And I no longer need parentheses because there's nothing in front of it being multiplied. This sine and this negative sign cancels and leaves you with 1 over cosine, which we know is secant of theta. So anytime you have like a 1 plus sine, 1 plus tangent, 1 minus sine, 1 minus cosine, you can use this trick to actually turn it into something simpler by using its conjugate. Number 11. Now on this one, I noticed that I've got 2 terms and both of them have tangents. Another one of our strategies was to factor. I can take and I can factor out a tan squared out of both of these. So factor out a tan squared, you're left with 1 minus sine squared. So now that would be a tan squared times 1 minus sine squared by the Pythagorean identity is cosine squared. You can rewrite tan squared as sine squared over cosine squared times cosine squared. The cosine squares would cancel and leaves you with just sine squared, and our angle was a y. Okay, our last one, number 12. We have sine to the third, and again, notice the top. We can factor the top. Both of them have sine to the third, so let's do that first. So sine to the third times cosine or cosecant squared minus 1 over cosine to the third. Inside of these parentheses, cosecant squared minus 1. Anytime I see those ones and anything squared, I start thinking Pythagorean. And you can see this one right here, cosecant squared. If I were to move that 1 over, cosecant squared minus 1 would equal cotangent squared. So let's go back and replace this with cotangent squared. So I now have sine to the third times cotangent squared over cosine to the third. Now sine over cosine right here, we could split that. And sine to the third over cosine to the third would be tangent to the third times cotangent squared. Now let's see if we can clean this up a little bit. I know tangent is equal to sine over cosine. I should have actually just left that. Sine to the third over cosine to the third because I just dug a hole and then I filled it in. Cotangent would be cosine over sine, so it'd be cosine squared over sine squared. So 2 of these sines would cancel with 2 of these and leaves you with 1. 2 of these cosine cancel with 2 of these and leaves you with 1. So we're left with sine over cosine, which we know is tangent. So we have the tangent of x.